Okay, this video lesson is going to go along with what we learned in class. Okay, so we're taking out the greatest common factor. Let's just look here at the first couple things. If you have two numbers, 8 and 6, I could take a number out of both of them. The biggest number that I could take out of both of them, I can't take a 3 out. 8 doesn't divide by 3. I can't divide a 6 by a 4. The biggest number that they both have would be a 2. I could factor a 2 out of them. Okay, this is just a warm-up for factoring. Now, if it's 8x and 6x, I notice they both have an x. So could they both donate an x? Yes, I could factor an x out of both of them. And I could take the number 2 out. So 2x would be the greatest common factor. If it's 8x squared and 6x, could I take 2 x's out from each of them? No, this guy doesn't have 2 x's. He only has 1 x. So they could each give away an x. I could divide out the number 2. So it's still 2x that they have in common. Okay, so we're looking for common factors. If it's 8x and 6, this guy doesn't have any x's. So I can't take an x out of each of them, as he doesn't have any. So I'm only going to have to be able to take out a number. I'll take out a 2. That's the only thing they have in common. This guy is made up of 3 and 2. And this guy is made up of 4 and 2. And an x. So the greatest thing in common would be 2. Take a look at this. This is getting juicy. Okay, let's look at it one at a time. What number could I take out of both of them? Could I take out 2? Could I take out more? I could factor or divide out 8. They both have an 8 they could give up. How about x's? I notice this guy has 1 x. This guy has 2 x's. So how many x's could I take out? I can't take out 2. He only has 1. They could each give up 1 x. And then how about the y's? He's got 2 y's. And this one only has 1 y. So I can't factor out 2 y's because he doesn't have enough, but they could each donate 1 y. Okay, that is the skill we're going to be doing in today's lesson. First, let's just review distributing. Distributing means to multiply in. Okay, but when there's parentheses, and there's 2 terms in there, the question is, who do I multiply the 3x by? Do I multiply it by the first term? Or do I multiply it by the second term? And distribute means you distribute to all of them. It's like distributing candy. Everybody in the class wants to get the candy. So 3 times invisible 1 is 3. X times x is x squared. Okay, 3 times positive 4. That's going to be positive 12. And then give him an x, so he's only got the 1x. These are not like terms. They cannot be added together. Okay, so distributing is what we've been doing. And then today in class, we were talking about factoring out. Factoring out. So let's look at the numbers. 3 and 12. Is there a number that they both have in common that I could take out? I can't take a 4 out of the 3. He's only a 3. Could 12 be divided by 3? Yes. Okay, so I'm going to take out the number 3. Now let's study the x's. He's got 2 x's. He's got 1 x. So how many x's could I take out from each of them? I can't take out 2 x's, but 1 x is the most. They each have 1 x to give up. Okay, so then I open parentheses here. Okay, so he had a 3, but I divided it out. He had 2 x's, but I divided 1 away. How many does he have left? He just has that 1 x. Okay, and then 12 divided by 3. That leaves us with positive 4. He had an x, but I took it out. How do I know if that's correct? If I distribute it back in, does that make the problem? 3x times x, x squared. 3 times 4 is 12x. Okay, so this lesson here is going to show you a variety of examples where we're factoring out, but you could always distribute into check. Okay, let's take a look at the first one. The first problem here is pretty small. It's just 3 plus x. So let's study one thing at a time. I look at the numbers. They each could be divided by a 3. Could I take any variables out? Well, the second term has no variables, so there's no letters to divide out. So 3 is the greatest thing that I could take out. 3x, I divided out the 3, and he's got x left. Is that right? Is 3 times x 3x? Good. Plus 6 divided by 3 would leave us with a 2. Okay, let's take a look at number 2. Ooh, this one has some negatives. Okay, if it starts with a negative, we're going to take it out. All right, we don't want our polynomial to start with a negative, so I'm going to factor out a negative. And now let's study the numbers. 3 and 6, I could take out a 3. How many x's? He's got 2. But this term only has 1x. So I can't divide out 2 x's because he only has 1. So the greatest number of x's would just be a single x. Okay, then you put your parentheses. So he had a negative, but I divided it out. He had a 3, I took that away. He had 2 x's, I divided one of them out, and he's left with just an x. Is that true? Negative 3x times x would make negative 3x squared? Yes, good. Okay, now 6 divided by negative 3. A positive divided by negative is negative 2. He had an x, okay, but I took it out, so I think that's all he has left. Is that right? Is negative 3 times negative 2 a positive? 3 times 2 makes 6. Yep, that works. Okay, you can distribute every single problem and check to make sure they're coming out right. All right, how do you factor a trinomial? Okay, now we got to look at 3 things here. The number that they all have in common. I always look at the smallest guy because all he has is a 3. That's all he could give up. Could they all give up a 3? Absolutely. Okay, now how about x's? Could they all give away some x's? No, 9 doesn't have any x's. Okay, so the only thing I could divide out is a number 3. All right, parentheses. So we're going to get a trinomial in here. 3x cubed, I divided out the 3. All he has left is x cubed. Positive 6, I divided out a 3. 6 divided by 3 is positive 2x. 9 divide out a 3 is plus 3. Now you could always look at this trinomial. Did I miss anything? Was there any number that I missed? Nope. Are there any x's that I missed? Nope, he still doesn't have any. If I give them all the 3 again, does that make the problem? Yes, it does. Okay, some people actually go like this. They say, I'm going to check. I'm going to give 3 times x cubed. I'm going to distribute 3 times 2x. And 3 times 3 makes 9. Perfect. It made the problem. Okay, distributing and undistributing. All right, number 4. If the problem starts with a negative, or if they all have negatives, then we're going to take out the negative. Okay, if it starts with a negative, factor it out. How about the number now? The thing in common between 7 and 14, they could both be divided by 7. And how many x's can I take out? They both have lots of x's. I could take out 1, but I could take out more. He has 2 x's he could take out. And he could give up 2 x's, so x squared is the correct answer. Negative 7x squared is the factor I'm dividing out. Okay, so he had a negative. I divided it out. He had a 7. I divided that out. He had 3 x's, but I took 2 of them away, so now all he has is 1x. Okay, negative, but I factored out the negative. So now he's positive. 14, but I divided out a 7. So now he's only a 2. He had 2 x's. I took both of them out. I think this is the right answer. Let's just check. Okay, negative 7x squared. Negative times positive is negative 7. And that would be a total of x cubed. A negative times a positive would be negative 14x squared. Okay, looking good. All right, let's go to number 5. Okay, lots of letters, lots of positive signs here. All right, let's take a look at the numbers first. What number do they both have that I could factor out? He only has a 2. I can't take out a 4, so 2 I think is going to be the biggest number. Now let's study the x's. He's got 2 x's. This term has 1 x. So I think the greatest number of x's I could take out is just 1 x. That's all he's got. Now let's study y's. There's 3 y's and 2 y's. So I could take out a total of y squared at most. He only has 2 to give up, so I'm taking both of them away. All right, parentheses. If there's 2 terms, we're going to get a 2-term binomial here. He had a 2, I took it out. He had 2 x's. I took 1 x out. That leaves us with 1 x. There were 3 y's. I took 2 of them out. That gives him just 1 y left. Okay, 4, positive 4. I divided out a 2. So that makes him a 2. He had 1 x, but I took it out. He had 2 y's, but I divided that out, so that's all he's got left. Was there anything I missed? No, that's it. So I'm going to go ahead and check this one, make sure I'm doing good. Okay. 2 times 1 is 2. X times x, that makes a total of x squared. Y squared times y is y cubed. Okay, plus 2 times 2 is 4. And then you've got the x, y squared. Was that the problem? All the numbers worked out? Perfect, it checks. Okay, I'm going to save number 6 for class. If you feel like trying it right now, you could try it at home, and we'll go over it when I see you next. Thank you.